And this is my equation number 3. So the problem remains to find out A and B. I need to find out the solution of equation 2 and 3. And this, the solution of these two equations will give me that A will come out to be as f of I minus f of I minus 1 upon xi minus xi minus 1 minus f of I minus 1 minus f of I minus 2 upon xi minus 1 minus xi minus 2. So this will be my A. My B will be this A times xi minus xi minus 1 plus fi minus fi minus 1 upon xi minus xi minus 1. So this is my B, and my C is nothing but f of I. So that means I have the polynomial A x minus xi to the power 2 plus B x minus xi to the power 1 plus C, and that is nothing but A delta x square plus B delta x plus C. And I know the value of A, B and C based on the function value and the guessed values. So that means I have this polynomial. Now the task remains that I need to find out the root of this polynomial. So the root of this polynomial is that delta x is equal to minus b plus minus root of b square minus 4ac upon 2a. So this is my root of the polynomial. This is my root of the polynomial. This delta xi is nothing but xi plus 1 minus xi. Since the root of the polynomial at the root x is equal to xi plus 1 for that particular iteration, and that is nothing but minus b plus minus root of b square minus 4ac upon 2a multiplied. So I'm doing this multiplication thing. This is multiplied by this plus minus root of this b square minus 4ac plus b upon plus minus root of b square minus 4ac plus b. So basically I am this I am making as plus and I am multiplying and dividing it. So that will essentially make it as this will be minus b square plus minus b square minus 4ac. So let me do it again. I mean, just to explain this to you, let me do it again. That delta x was nothing but minus b plus minus root of b square minus 4ac upon 2a. Now there is this condition that so that will make as xi plus 1 is nothing but xi minus b plus minus root of xi plus minus b plus minus root of b square minus 4ac upon 2a. Now if we do some mathematical manipulation with this, that suppose if this is, so basically what will come out of it is that it will give me xi plus 1 equal to xi minus 2c upon plus b root of plus minus b square minus 4ac. So this will come out of it. Now here what I am doing, I am multiplying this with this plus b plus minus root of b square minus 4ac upon b plus minus root of b square minus 4ac. So that will give me, and this will give me that this will be minus b square plus minus b square minus 4ac. So they, in the numerator there will be minus 4ac, while in the denominator with this 2a will be there, and plus b plus minus root of b square minus 4ac will be there. So this 2a will cancel out this 2a. So in the numerator there will be minus 2c only, and then in the denominator we will have b plus minus root of b square minus 4ac. Now, so what we have, essentially we have this xi plus 1 is nothing but xi minus 2c upon b plus minus root of b square minus 4ac. Now the idea is that the sign of b, the sign of this plus minus, whether it is plus or minus. So this will depend that we want to plus minus root of b square minus 4ac. We want to maximize this. That means the sign must agree with the sign of b. So suppose if b is positive, then we will take plus sign, and if b is negative, then we will take minus sign. So the point is that we want to maximize this denominator so that our root is very close to this xi. So that is the idea. So we have this xi plus 1 equal to xi minus 2c upon b plus minus root of b square minus 4ac. At every iteration I will calculate a, b and c. Then I will put the value of a, b and c into this equation, and based on the sign of the b I will choose the sign of this plus, this either plus as or minus, to maximize this denominator, and then I will compute the value of xi plus 1. Now the question is that I have xi minus 2, I have xi minus 1, I have xi, and based on this I have computed xi plus 1. Now what will be the strategy for the next iteration? I mean, whether I will replace sequentially, or so what will be my strategy? So if so the selection, so for the next iteration I want, for the next iteration I need 3 points. Now the question is that which of xi minus 2, xi minus 1, xi plus 1, which of the two among xi minus 2, xi minus 1, xi will go with xi plus 1. So for the next iteration xi plus 1 will be there, but which of these xi minus 1, xi minus 2 and xi will go with xi plus 1 for the next iteration? So the idea is that if so I am giving you two statements. First is that if only real roots are being located, then we choose 2 points among xi minus 2, xi minus 1, xi that so we choose 2 points among xi minus 2, xi minus 1 and xi that are nearest to the estimated value x3. So if we are looking for only real roots of this this polynomial, then we will choose 2 points among xi minus 2, xi minus 1 and xi such that the 2 points are nearest to the x3. The second idea is that if both real and complex roots are being evaluated, a sequential approach is employed. So we will basically take xi minus 1, xi and xi plus 1 for the next iteration. We will degrade xi minus 2. So that's the idea. So as I told you in the beginning itself, that here this Muller's method is popular for the polynomial functions only. So polynomial functions can have real roots or they can have real as well as complex root. So if we are interested in only real roots, then our strategy will be that we will choose 2 points among the xi minus 2, xi minus 1 and xi such that the 2 points are nearest to the x3. But if we are looking for the real as well as complex roots, then we will go in sequential manner. So we will degrade xi minus 2 and then we will go with xi minus 1, xi and xi plus 1 as an initial guess for the next iteration. So in the Muller's method, I will explain that we will basically calculate A, B and C. Then we will find out xi plus 1 as xi minus 2c upon b plus minus root of b square minus 4ac, where if b is plus value, then we take plus sign. If b is minus value, then we take minus sign. So after doing this, we have this xi minus 2 and xi minus 1 and xi plus 1. Now if we want only real roots, then we will choose closest points to xi plus 1. If we want real and complex root, then we go sequentially. So we choose xi minus 1, xi and xi plus 1. So that is the idea, that we will go sequentially if we are looking for real and complex root. So this is the basic principle of Muller's method. I will give you one small example in the next video so that you can understand it better. Thank you.